Hi everyone, this video is to show you how to use multisim and Ultiboard application to make the PCB design. For this video, I have chosen a circuit laser security alarm. Okay, it works based on LDR, op amp LM358 and 555 timer and a few other basic components and one buzzer for alarm indication. Since you have the circuit, we have to design this in multisim application where you can do the simulation. After simulation, we will export all the components to Ultiboard to make the PCB design. So here we go. We will do the multisim design for the simulation. This is the area you can place the components. You can use these options to search for the components whatever you need and you can place it on it. Then we'll make the connections. If you want basic design circuit designs, you can see my previous videos. Now in the circuit, key parts are op amp. You can see, you can find here place analog. Click on this. There are many types are there. You can search in this window, like you can type the number LM358. See there in 358 there are many in this family, so I'm gonna use LM358 AD. Click OK. In this again we have two parts, A and B. I'm gonna use one part which is having two inputs and one output. Then I need one 555 timer. 555 timer will be available in the same category right here. It's not coming. So whenever if you don't find any component easily, you can go for the search option. Click on search, write component 555 timer and search. Let's go back. Let me search again. Now let me search again. Come on. No. Oh no, it's not getting it. We must get it actually. Let me try again. Oh, there are many. See here you can find 555 timer. Yeah, just select this and click OK. You can find here. Like this, you can share, you can search for the components and you can place whatever the component you need as per the circuit you have choose. Okay, so once I place all the components, the circuit will be components will be like this. Once you have all the components in the pan, you have to do the connections. Connections are making connections is very easy. Just click and drag and click again. It's quite easy. Make all the connections as per your circuit diagram. Here you go. We made all the connections. At the moment, LDR we cannot simulate directly, so I place uh, fixed resistance 10K, and we have one potentiometer for reference value. So based on the potentiometer position, op amp will compare the input and it will activate the output. That output is being connected to 555 timer trigger. So 555 timer output is connected to LED for indication and a buzzer for the alarm sound. Since you have all the components and all the connections are ready, we can do the simulation by using this option run. For shortcut, you can use function key F5. Now, initially, start the simulation. Initially, the output from the timer is 0. So LED is not showing any indication. If you change your reference point by using potentiometer, op amp will compare the inputs. It will compare the input from LED and this potentiometer, and it will give the output. Okay, now 555 timer is output is activated and this LED is on. Eventually, this buzzer will be on. Since our circuit is working fine, we can do the next step like Ultiboard applications. Okay, Ultiboard design. To do that, just export these components to Ultiboard application by using this option. It will ask you to save the circuit. Just save it. Then it will be exported to the Ultiboard. Now here is my circuit. All the components are here. You can recheck your footprint whether it is convenient for you or not. According to me, I got very good footprints. If any footprint is not good, just go back to your multisim circuit, go to properties and change the edit footprint package and change it as you want. Now, since you have all the components here, we have to use available options here and you have to make the design. First, we have to keep all these components inside this working area. So to do that, we have to select this option, enable selecting parts. Select this option where you can select the components. You can move the components. Now you can move all the components at a time. Now arrange the components as per the circuit layout. Same placements same placements you have to use so that your circuit will be easy to understand. Okay, place the power source V1. It will have a name. By using that name, you can identify the components. Okay, if you want to turn the components, select the component and control R. Then go back to circuit R8 and LED3. Arrange it in properly. R8. Here is my R8 and sorry, it's R8 and LED3. The next one would be LDR and R2. Go back. Here is my LDR and R2. The next one will be R3 potentiometer. Just make the area free. Find out potentiometer. Here is my potentiometer. Forgot the switch. Here is my switch. Then op amp U1A. See, here is my U1. Keep it here. Followed by LED and resistance for R4 and resistance R5, R4 and R5. R4, R5 and LED 2. Rest all you can move it to away from this area so that you can arrange the component nicely. Then 555 timer U2. R6 and C2 next to the timer. R6 and C2. Here is R6 and capacitor C. Now we have resistor for the output of the timer and LED, and we have LS1, which is alarm. Once you arrange the components, you can rotate the components for having less conflicts within the wires. So if you have less conflicts, you will have less errors. Okay, the connections should not connect each other. There should not be any short circuits. The yellow line shows you the legal connection of the main circuit that you made in the multisim. Now everything is ready. We will have two options. One is automatic routing and another one is manual routing. I always prefer to do the manual routing. Manual routing will give you less errors. To do that, select this option, follow me, and click it and connect it. It's a quite easy one. Once you make the connections, you can arrange them as you want. Yes, the design you like. Once you make these connections, you have to increase the width of these lines. Okay, either you can do it individual selection. Select this option like enable selecting trace. Select the line and go to properties and change the width in general. Width I want to keep it 30 and the clearance I want to keep it 30. Okay, if you do this, the thickness will change. See, this red circle means there is an error, which means it is close to the another terminal. Just move it away so that you can find proper connections. If you do individual line, it will take a lot of time. So in one shot we can do in shortcut. It's like deselect all the options, only select the line and Control A will automatically select all the lines at a time, and you can increase the width at a time 30 and the clearance is 30. Apply. See, you can see the difference now. And another important selection is pad diameter. See, this blue circle is a pad to insert the electronic components. Its size is too small, so this will not good enough for the soldering process, so we have to increase the diameter and other parameters. To change this, select this option called THT pad. Okay, select that pad, go to properties, change the pad option to, now it is 50, make it 75, and drill, make it 30. Okay, apply. Then you can see little better pad size so that you can do good quality soldering. If you do this process for each uh, pad, it will take a lot of time. You can do it in a single shot. Deselect all the options here and select only THT and Control A. Automatically it selects all the pads. Then go to the properties, change the diameter to 30, sorry 75, and drill diameter 30. Apply. You can increase the size of each pad at a time. Once you make this, we are ready to do some graphic work. Okay, since it is a training video, I did not make the process for uh, all the lines, so that it will take a lot of time. So I want to make it short. Just make the connections and increase the width size, and then you have to do some graphics. See, our board's working board size is too big. We don't need this much size. We have to reduce the size of the board. Select the border outline and selecting other objects option so that you can vary the size of the board. Reduce it. Here you go. Now let us insert some graphics. Place graphics rectangle. Then select the board. Sorry. Go to the copper top. Every time you are making changes, you have to work on copper top. Okay, this is how to apply the graphics to the board. Finally, if you do the wiring for all connections, you will have a board like this. Okay, here is my final board. Once you have final board, if you want to add any text, you can do that by using this option. Okay, so just click on text, a window will pop up, write down whatever you want to write, name, Just click OK and place it wherever you want. Okay, if you want to increase the size to 100 mil. So write name. So you will get little bigger one. Okay, suppose if you don't like to keep the text on the board, you can go back to this option, selecting attributes, then select the data and delete it. Select and delete. Okay, this is my final board. Sometimes assessors will ask you the 3D view of your board. Okay, to show that you have to use this 3D view. Click on this. You will find the 3D view of your design. Here you go. It will show you the 3D view with all the lines and the components. Now, once you have this 3D view, we have to go back to our circuit to print the board. Where is my board? Yep. We need to take a printout which is required for chemical process. Use Ctrl P. Yes. And go for the preview. In this preview, copper top silk screen top will show you the placement of each component, and copper top will show you how the PCB will be. We will take this printout on A4 paper, white paper, and we will use it for the UV exposure and developing process and etching process. Okay, if you have any questions, please comment below. I will get back to you. Thank you.